Here in this video, I will be giving some brief information about the normal distribution, which is the most popular distribution for a continuous random variable. And the idea is the following. So, the normal distribution usually comes with two parameters, the mean and the standard deviation. Once you're given the mean and the standard deviation, say for instance the mean is 100 and the standard deviation is 15, it is possible to construct a normal distribution. Let's go ahead and do that. Normal distribution with these two parameters. So in a sense, normal distribution has two parameters, the mean and the standard deviation. All right. So what I will do is the random variable can take any value. In average, the value will be 100, obviously. So let's just go ahead and draw the draw it on a graph. So here we have the probabilities. So the mean is at 100, and it's customary to go one standard deviation to the left and to the right. So 115, 85, add and subtract 15. Then go two standard deviation to the left and to the right. So 130 and 70, and so on. Right. So maybe I don't need this with this way. All right, there we go. And then you can go three standard deviations, 55, and then we can go one more standard deviation to the right, 145. So it will be a bell-shaped curve. Let me just go ahead and use a different color for that. Let's use green, for instance, where the mean will be 100 and the standard deviation will be 15. So it will look like a distribution which looks like a bell curve. So it's also known as a bell curve. Sometimes this is referred to as a Gaussian distribution, Gaussian by Gauss, the mathematician from the 18th century, German mathematician, Gaussian distribution. The key idea is the following. A normal distribution is symmetric around the mean, so that's the mean. So usually we refer to it with the letter mu. And you can see one standard deviation, like within one standard deviation from the mean. So this area over here, mu minus sigma, mu plus sigma, sigma, in this range. In our example, mu minus sigma is 85, mu plus sigma is 115. The probability that the distribution will be within one standard deviation, the probability that our random variable will be between 85 and 115 will be equal to, well, it's equal to the area, this area over here underneath the normal distribution. Notice that the whole area is 100%, right, underneath that distribution, because it's a probability distribution after all. It turns out that this is approximately, let's write that down, approximately 68% for a normal distribution within one standard deviation. Within two standard deviations would be a little bit a bigger area, right? So we're talking about now between these two red lines. So the area of the curve between these two red lines, this area, obviously it will be a bigger portion. So between, let's write it in green again, between 70 and 130, this will be approximately, if I'm not mistaken, it should be about 95%. I'm not quite sure on that one, so we might need to use some sort of calculator or Excel to do it, but it's very straightforward using Excel to make those calculations. And finally, let's check three standard deviations between 55 and 145, right? So 55x 145, this is very high, more than 99%. I think it's more like 99.9%, something of that order magnitude. Why is the normal distribution so popular? Because it is abundantly available in nature. The height of males, adult males in San Antonio, for instance, area, they are distributed in a normally, right? So for instance, it might be the height of adult males is normally distributed with a mean of 5 feet, I don't know, maybe 7 inches, with a standard deviation of 2 inches. Does that make sense? Inches. So it is normally distributed. So when we say the height, then, so it will look like a bell curve again. And the mean is 5 feet 7. And one standard deviation to the left is 5 feet 9. to the right, I should say. 1 standard deviation to the left is 5 feet 5, so subtract 2 inches and add 2 inches. If you go 2 standard deviation, does that make sense? And then you get some more. Okay, but that's the normal distribution. It's a symmetric distribution. You have the mean, and nicely the values are distributed symmetrically around the mean. Just as a business example, consider the profits of a company. Suppose that the profits of a company are normally distributed, where the mean is $1 million and the standard deviation is, say, $500,000, 500K. All right, so then the question is, problem. What is the probability that the profits of this company will be less than $0? So the company will have a loss next year, given that the profits historically has been normally distributed with $1 million. In average, the company is making $1 million profit a year. However, there's a standard deviation. There's a risk involved, and that risk is $500,000. So given this feature, so we can calculate the desired probability that the profit is less than $0. So we can first, let me go ahead and draw a picture. So we are told that the mean is 1 million here. The standard deviation is 500K. So this is 1.5 million, I guess. Does that make sense? So the mean is here of our distribution. There you go. So this is the topmost point. The picture doesn't look symmetric. There you go. So this is the topmost point. It's kind of a curved. So let's do it like a curve. Oh gosh. All right, there you go. So the question is asking for because this is $0, the question is asking for the area to the left, on the left tail. What are the chances, given that the profits are normally distributed with a mean 1 million and standard deviation 500,000? What is the probability that the company will make a loss next year? Very unlikely, right? So for that, we can use Excel to accomplish that. So let me just go ahead and open Excel, and then let's solve this question using Excel. So I can read our solution so far to Excel. The solution should be very straightforward. So we have the mean. Let me write down the given so far. The mean is $1 million, I assume. Wait, is this enough? Oops, hold on. Is this 1, 2, 3, 1, 2? No, that's 10 million. Let's get rid of 1 0. In fact, let's just write it in dollar terms. It's even better. There you go. $1 million. The standard deviation is 500,000. 1, 2, 1, 2, 3. Again in dollar terms. Let's just go ahead and put $sign and get rid of the cents. All right, and we know that we are normally distributed. As we did previously, we are going to use. We want to find the probability that the profits, let's just say x is less than $0 basically. So that's what we want to find. Let's make a note here that let x be the profits. All right, so we just use the function normdist. Very straightforward. We want to figure out the probability that it will be less than 0, given that the mean is this number, the standard deviation is this, and we want cumulative true. Close parenthesis and boom. So the chances that this company will have will make a loss is very slim. 2.28% chance. Every 30 years or 40 years or so, the company will have a bad year. But in general, for 39 of the 40 upcoming years will be a good years. So the area in this tail as a result is only 2.28%. So the majority, so this is where the majority is. So 72% chance the company will have a positive profit. Yeah, that's a very straightforward application of normal distribution. What if, okay, let's change the question. What if the question is asking for the chances that we will have our profits will be between 0.5 million or 500,000 and let's say $1.5 million. So what are the chances the profits are in this range? Well, that's easy. Norm dist. So we want to find the area to the left of 1.5 million and subtract from it the area to the left of 500,000. Well, 1.5 million, 1500, 123. The mean is this number. The standard deviation is this. And true for the cumulative minus norm dist, like we said, norm dot dist, 500,000, right? So to the left, we need to subtract to the left of 500,000. The mean is this number. The standard deviation is also 500,000. And then we want true. That's it. So the probability is 68%. And are we surprised? Not at all, simply because we knew it, that within one standard deviation, this is exactly the range, right? Within one standard deviation, 68% of the distribution was within one standard deviation. That's 68%. Does that make sense? So if the question is asking for the probability that the profit will be between 0 and say $2 million, so that would be 2 standard deviations, right? So that would be, so let's quickly do it. Norm dot dist 2 million, 1, 2, 3, 1, 2, 3. The mean is 1 million. The standard deviation is 500,000 and we want true. Subtract from that norm dist again, the 0, I should say, and the probability between 0 and 2 million. To the left of 2 million minus to the left of 0 will give you the range between them, the probability of the area between them. The mean is 1 million, the standard deviation, and we know the answer should be true, because within 2 standard deviation from the mean was 95%, and there it is. If the question was 3 standard deviation, it would have been 99 point something, very high. All right, so that was a very nice, I hope, application, a business application of this. There's quite a few places you will see normal distributions, especially when you build confidence intervals. Whenever you run a regression analysis, we will be able to make some predictive analytics based on those regression analysis, and the predictive analytics, the reported parameters will come with a confidence interval which is based on a normal distribution. Hope you enjoyed it, and looking forward to see you guys in our next lecture.